Okay, we have just started this thing. Well, great. Let's write some notes for offboard node mode. So here is the thing. Mav, as you have seen in the PX4 message tab, that there are a lot of different messages to control the lot of different topics, a lot of different subscriptions, a lot of different options. Mavrose is actually giving us to control the complete node. So basically, here are the sum. So to get the local position of the drone, we need geometry message. State is the offboard or onboard state. This is the service provided by that. And these are the services of the Mavrose messages. We need to give command, request command, set mode, and these. First, we have defined a function. So this is a function. So this code is not mine. This code is I have borrowed from the official repository of PX4. And then actually what they're doing here is that they are subscribing. So I mean, state subscription is the subscription of this Mavrose state. This is somehow a topic. You can just go to rows topic list somehow. Okay, just a moment. We need to source this again. Source devil bash and then rows. Why? Okay, since I have installed multiple rows version, I have to check that which version it is. Just a second. Sorry, I'm completely confusing the command of rows 2 and rows 1. In rows 1, actually, we write rows topic list, right? And here are the rows topic all together because we have run this already, the drone. Now, as you can see that we can get now all the messages here. So the topic, there would be some topic, state. Well, there is always, all the topics are here for all the status. This is the IMU data raw. It's beautiful. We can use that one too later on. This is the mission waypoint. Cool. We can give some multiple mission to the, this is the trajectory for path planning. Well, this is the map state. And we have actually subscribed to this topic here. Right, similarly, we can subscribe to the wait for service or service. This is again Mavrose command arming. Right, so this is a rose service, not a topic. This is Mavrose service. And we have altogether a lot of services, right? And this is a very good thing. So what we have done very quickly, we can do is the, okay, we have actually some sources, some message, and some topics. Subscribe. This is for arming. This is for setting mode, right? This is again now service proxy. This is the client. 20 Hertz is the minimum rate the communication should happen between the Mavrose and Mavlink to work this node. You can increase this, but this rate is 22 Hertz, right? And here's the position. Pose is the post stamp, the position stamp. what we have called here 0002. We can say that just go to 2 meter up in the air. Well, okay, local pose publication pose. Okay, then it's now requesting this offboard set mode, what we have said above. Right, it's requesting that, and mode is the custom mode, which is offboard. Arm command is the command we are requesting, again command, and arm command values is equal to true. So last request, this is the time, and now it's actually measuring the time from the last request to the time now. And time elapsing, not if time not elapsing more than 5, it's enabling it. And this is how it's publishing pose, right? And this is the Mavros topic position local. Queue size is 10, but you can increase queue size here. Now this is the topic of internal topic. So there are some topic or services that coming out from the PX4, and there are some topic called input topics to get in the topic. So this is right now the in like in simple words, PX subscribe some topic and publish some topic. All those topics PX4 publishes, you can subscribe to them to monitor the drone or control the drone. And if you see here, actually there would be some Mavros set point position. Set point position is the topic. Set point, I don't know, can we, oops, set points, Mavros set point, I don't know. Yeah, there is the local, here is the global. So this is the topic responsible for sending the command that go there at this position. So what we are doing here, we are creating a pose, any pose here. So this is our pose. Actually pose is the we are initializing the pose function, let's say like that, what we have imported. Meanwhile, we are saying that we want this drone to be offboard position right now, and after it's request is made, then here we are managing a little bit for getting it enabled and armed. And when it's getting armed, after that we are just publishing the pose to the topic, nothing fancy. So it's very simple. It is just a local pose publication. So publisher. So there are some topic topic subscription options given by PX4. So you can just publish these. So PX4 has actually subscribed to some topics to take control of drone and take command from outside board. So here is the rose publisher, and publisher is actually getting the pose, and in the end, actually after that it's let's see if it's working or not. So make sure that this is working okay. This is very annoying error, but I need to later on change this. And if I get rows run robox and offboard, oh, Okay, offboard mode is enabled. It's a little bit slow. My system is also a little bit slow. And as you can see that it's transparent. Let's do it transparent. And it's going upward. Well, this is now local position and it's going upward. Great, that means it is working right now. So that's how the offboard control is working actually. Great. Next step, in the next step, we are gonna see how to give waypoint, goal list, or maybe then after that we can see how path, we can install some customized word into it, and then we can see how we can do mapping stuff and navigation stack and all together other things. And by the way, if you want to see how this works in rows 2, let me just show you how it works in rows 2. So that's how actually the output control for rows 2 is looking like. Because you can see here that we are working with colcon here, and we need to first compile the package colcon, package select roscom communication package, and then message. And then actually what's happened is that we can import some messages, whatever is message are necessary to import. Like similarly, we are just importing some messages that are necessary here. And then we are again with similar way. Here actually there is the super node, there is the node written in the the Python package, and this is the main node. We are just inheriting some functions from this node output control, and then actually we are just creating all these functions are written in this node, and then we are just subscribing some topic here. And you see that the counter is necessary that default time tracking. And then actually what we are doing here that we are just if you go to the documentation of Mavlink, it's gonna set if it's gonna tell you that what this 1 and 6 is meant for. 1 and 6 is 1 and 6 is for setting the mode actually, and then you can just publish this topic similarly, and after it's not reaching up to the like after this the callback function actually is regularly and continuously time back function. Whatever function you have written here is continuously running, and when it's run to the iteration number 11 and then it's set to the 0 again, this publisher here. And similarly you're just defining some function to give it command. This is the vehicle command. This is very similar what we have seen right now. This is to publish positions, this is to publish a trajectory if there is more than one. And yeah, somehow these are the message you publish, and in the end after the main function you have actually trying to say that, well, that's what you're saying that, okay, well, this is the timer function, and if this is the main actually function you have defined here, and you are doing this. So that's how actually you can do this similarly in the RCLPy. In the rows 2 it's called RCLPy, and then you can just spin it offboard control a main class and then it's gonna do the same. So pretty much same stuff. The only difference here is that Mavros has different style of messages and sources and clients, subscription and publication style, and there is one layer working. First, Mavros have to communicate with the PX and then modify those messages and publish them itself from its own layer, and then we have to take control. And there is a middleman sitting in between these two nodes. There's PX, there's like rows, and then for communication we need the middleman in between. So that's how Mavros is the middleman. But in this case, you can see that this is native communication protocol of rows 2, and you can just directly get into, or you can directly control the PX4 without any middleman. That's how this is the big benefit actually this is giving. They Those too skinny, but yeah, that's everything about the off node control. And next step, we will do more customization. We'll actually do some more stuff in without any offboard control. We can write real code to control the drone and send to different locations and so on and so forth.